In order to facilitate sliding of the gearbox, we have hydraulic cylinders that are placed on both sides of the gearbox and provide stability this direction, right? So in the longitudinal direction. In the lateral direction, we have stability provided by the pylons, which bear the mass of the gearbox, which now then sliding action is provided by these cylinders. Now, to permit sliding, we have roller mechanisms that slide on this rail right here. And this is simply integrated into the fuselage. So this groove, right, it's simply the groove in the fuselage structure, the upper fuselage structure. The sliding unit we can load up in a moment will resemble something like this. The two rails that we mentioned before, alright, these two items here, that would be these two rails right here. Okay? And these rollers, this would be the load-bearing roller, and this would be the roller that carries the weight of the gearbox section. Right? So it's carrying considerably less load. And so these actually would be larger. This is not a perfect model. This is one of the first models. These rollers at the bottom would be much larger because they're carrying significantly higher load. These rollers, we have a model of the roller, which I will bring up in a moment. Now, before I bring up the model of the roller, we can demonstrate what we call the strap mechanism. Again, this transfers the weight from the rollers to the gearbox pylon. This is carrying the entire load of the aircraft. These are actually fiberglass beams that are very similar in their construction to a rotorcraft flex beam for a rigid rotor system. Now, roller mechanisms, if we so we have bearings here in the roller mechanism, 3 sets of bearings in this case. Okay. And so we can go through our different modules. This is the beam/rail module, which fits right here. Remember, this is highlighted. This is the weight-bearing strap module. Okay. These two modules right here, they're one piece. Okay. And then our roller module. I can bring up the roller module right here. It should be loading right now. Okay, so this roller module varies in size, with the lower roller modules being greater in number, so we would have probably 3, and they would be larger diameter because they're carrying significantly more weight than the upper rollers. The upper rollers simply bear the weight of the gearbox assembly on the fuselage. Then our rail module is integrated with the fuselage structure. Okay, so it's not compromising the structural integrity of the aircraft in any way. Then we have our cylinder module, our hydraulic cylinder module. This is connected to this structural member right here, and is actually connected to the engine in the rear, but we would simply have another structural member here that provides housing for the cylinder. The cylinder provides the actuation force, but it also gives us our stability, or lateral stability. Now there's an alternative design whereby bring this unit, we open this here. Here is the gearbox mechanism that's we went over in the first period of the video. And then we have our struts. These are our struts that provide the stabilizing connection, right? So these provide lateral stability. So in flight, there's a great deal of force that is applied to the mast. So the mast wants to bend, and this provides that stability. Now the weight would be carried over a single rail at the bottom of the gearbox, as illustrated. So here we would have a roller module right underneath, so all of the weight bearing connection would be underneath on a single point, on a single rail, and then we would have two additional rails on the side that are not carrying very much load. They are simply providing the stability. Okay, so we would have a member connect these two struts together. That way we have a rigid triangle structure, but that rigid triangle structure can slide, right? So it's rigid, so we have mast bending movements, let's say in this direction, right? It wants to move this way. Well, this strut, more tension will be applied to this strut, but it cannot move, right? Because it's connected to this arm right here, to this member. But of course, that force, right, will want to move it in this direction. That would be resisted by the cylinder. Rather than having two cylinders provide lateral stability, these cylinders are located in a lower position and simply provide the sliding motion, but also resist sliding motion. And so these two designs, this is likely the design that will prevail, although both designs are being considered. But this design makes the most sense because our load-bearing rail, rather than having two, we have one in the center underneath the shaft. So we have our strap and our rollers and our rail at the bottom. Then we have additional rails and rollers, but non-load bearing, simply lateral stability being provided. And then this is our shaft that's able to slide. Okay, so that's about it.